Welcome to episode number 911. I'm your host, John Krohn. Starting with today's episode, we're trying out much shorter intros. So I'll quickly tell you that you're in for a treat with today's guest, Dr. Akshay Agrawal. Akshay has built a clever open source replacement for Jupyter Notebooks based on the pain points he experienced with notebooks while completing his PhD at Stanford. Akshay is smart, well-spoken, humble. I think you'll really enjoy this one. This episode of Super Data Science is made possible by Dell, NVIDIA, and AWS. Akshay, welcome to the Super Data Science Podcast. Where are you calling in from today?
I'm in the Bay Area in Redwood City. Thanks for having me, John.
Classic tech founder, AI tech founder in the Bay Area. What are the odds? And you were introduced to me by Sean Johnson, who is an investor at AIX Ventures in San Francisco. And if people are interested in hearing an episode involving, what investors are looking for in AI startups and where the opportunities are for AI startups or anybody building AI solutions for enterprises, that's episode 895. It's a great episode. Sean is amazing. I guess you spend time kind of with him in person in San Francisco sometimes.
Yeah,
What's
I
your relation?
do. At the AIX office, I do spend time with him, and he is amazing. He definitely is. I've known him for how long now? A bit over a year. Yeah, and I'll see him usually almost every week.
Oh, wow, really? There, from what I could see in the background, and people can see it in the video version of 895, it's a beautiful looking office.
Yeah, the AIX office is very, very nice. Yeah, up in San Francisco. Yeah.
Nice. And so the reason why you're there once a week is because AIX has invested in your startup, which you are co-founder and CEO of, and it's Marimo. And so I want to start off with that name because our researcher Serge Massis dug up that Marimo means bouncy play ball that grows on water. And so it's a species of ball-shaped green algae native to Japan. Does that relate in any way to your company name?
I mean, yes. I mean, sort of. I can give you two stories, okay? Like the outer story and like the actual inner story. So the outer story is that Marimo is a next generation computational notebook for Python, data, and AI. And well, what are the previous generation ones, or what are related ones? So the one that most people know about are is the Jupyter notebook. Now, Jupyter, it's a very large sphere, a very, very large sphere. There's another notebook for a different programming language called Pluto JL. Pluto is a smaller sphere. It's kind of cuter, as some would say. And Marimo is the next generation one for Python, even smaller sphere, very adorable, very beloved by especially in Japanese culture, but also like plant enthusiasts. And like Marimo moss balls, like one thing that's actually cool about them is that they're actually assembled from like these like tiny strands of moss, like that all get clumped together, and they like kind of like live at the bottom of lake beds, and they like kind of like intermix and like mingle and um like together they're greater than the sum of their parts. And like Marimo notebooks, in ways that we might discuss, are sort of similar. Like they're collections of cells that, like when taken together, are greater than the sum of the parts. So that's sort of like the story conceptually of what the name is.
Nice. That
Also,
there's a lot to that. Yeah. Nice. Give
yeah,
me the also.
there's also an also, which is during like the pandemic, my partner and I, we had a Marima moss ball in our apartment, and we just like really loved it. And I were like, okay, like this is the thing, like we love this thing. Let's just call, yeah. It just makes sense. It also abbreviates well. Import Marimo as MO, which is you need that 2-character abbreviation for Python libraries.
I love that. That's a great story. And they are super cute. I wasn't aware of them before, but I looked at some, and so I'm gonna make a special request to our video editor Mario to overlay some cute photos from the internet of Marimo balls. Uh, yeah, to so that at least the people watching on YouTube can see some of those as you were describing it. And people who are in the audio only format, you're just gonna have to look it up if you're driving. Don't do it while you're driving. But when you get to a stoplight, check them out. They're super cute. Nice. So, your work at Marimo was inspired in part by reproducibility pain. So, anybody who has used Jupyter notebooks has experienced difficulties with reproducibility. And I have lots to go into around that later in the episode, but just as like a starting point, that kind of reproducibility pain that you experienced as a PhD student at Stanford, um, especially with things like co-authors handing you broken notebooks and model training often beginning without checkpoints, version control, or recorded data provenance. Um, Tell us about, yeah, those pain points that you experienced as a PhD student and how you came up with your solution.
Yeah, definitely. So I guess for a bit of background, so I did my PhD in machine learning, um, in it was like 2018 to 2021. So I did it at Stanford, and like I specialized in like vector embeddings, high dimensionality vector dimensionality reduction. So like finding structure in these like high dimensional spaces. And so when you work on things like that, like it's really important to be able to see your data while you work on it. So like notebooks and like Jupyter notebooks are like super useful. Like you just like without that iterative experience, like that kind of research is just like would be way harder. So like very grateful for working in Jupyter notebook for having Jupyter notebooks. Um, but like I guess as I did that research, like there were a few like shortcomings, some of them having to do with like reproducibility that sort of like came to the forefront as I like worked on them, like worked with Jupyter notebooks on an almost daily basis. Um, and so when it comes to like reproducibility and maintainability, I guess there's a few different aspects. So for one, um, the file format for Jupyter notebooks, they are stored as like these JSON blobs. Um, and so you can't like really reuse code across them easily without jumping through some hoops. So like you end up just like duplicating your notebooks for like slightly different experiments. Um, Whereas if you were writing software, you would just like import functions from one module to another. Um, but also this JSON blob like made like version control pretty hard because like you'll run a notebook, you might not even change any code, but like maybe the image changes or like some metadata changes, and you get like a big git diff. So it's like hard to know like how your experiment code also like actually changed over time. Another issue that would come up, and so like for some uses of Jupyter, like this is like a feature, but I'm about to describe. For some uses, it is a feature. For the kinds of stuff where like you're like no, you're doing science or you're doing data engineering and you need things to be deterministic, it is not a feature, in my opinion, at least. So in a Jupyter notebook, you can like run cells like out of order. So you can like say, you know, you can run cell number one, then cell number three, then cell number two, then cell number one again. And then maybe you forgot to run cell number three maybe depended on cell number one, and you just totally forgot and you never ran it. And the point is like now your program memory is in some like strange sort of quantum state that you don't understand. And then like you'll figure out like 4 hours later, 8 hours later, like, oh crap, like none of my experiment results are valid. And so like that problem is like kind of like broadly referred to as hidden state, and it just comes down to the fact that in a Jupyter notebook, there is no like the notebook runtime doesn't know how your cells are related to each other. Um, and so that was like a big pain point. Like if you contrast that to like an Excel, for example, like if you update a value in a cell, everything recalculates, and the world makes sense, and that doesn't happen by default in a Jupyter notebook. And I'm talking a lot, but like the last thing, and we can go into any of these, is like package requirements. Like so, like when you're working with a notebook, like you might forget to like track what packages. Like if you use PyTorch, like this specific version of PyTorch and this specific version of transformers, you might just like forget to like put that down in like a requirements.txt or a PyProject toml, like researchers often did. But then that means when you pass your notebook to someone else, they can't get the same results that are serialized in it. And so then that's sort of just another angle in which like this sort of reproducibility problem sort of uh, becomes sort of front and center.
All right. So, yeah, we're going to get into more detail on reproducibility, all of the issues over the course of this episode, all the pain points that probably many of our listeners have experienced, and the solutions that you have for them. So, I've got some of the key adjectives here around Marimo from our research. So, it's open source, it's reproducible, it's Git friendly, it's AI native, and it's a reactive notebook. So, a few things to dig into here. The open source thing, for example, you guys are doing very well 4 million downloads, I understand already at the time of recording, which is very cool. It must be amazing to see people, just voluntarily being like, this is a solution for me. I need this tool, something that you've spent all this time writing and developing and leading the product on. So that must be cool. But what I want to talk about is the word reactive here. Um, and so the idea is that it's a better tool. Marimo is a better tool because it nudges users towards better data science practice by being reactive in this way. Tell us more about that.
Definitely. Nudges is a good word. One of our users described it as gentle parenting. Um, okay, so yeah, what reactive means is it's just what it means is that Marimo keeps the code on the page in sync with the outputs you see. Um, so basically, say you have three cells. The first one says A equals 1. The second says B equals A plus 1. And the third one is C equals A plus B. And then you output those. You output the variable in each, right? So you see in the first cell, A equals 1, B equals A plus 1 equals 2, and then C equals A plus B, 1 plus 2 equals 3. Now, what reactive means is if you go back to the first cell and change the value of A from 1 to 2, the next two cells will, and then you run that cell. So you change the value of A equals 1 to 2, and then you run it. The next two cells will automatically run with the updated value of A. And so their outputs will update to, I can do this in my head, right? 3 and 4 or something, right? Like, so they'll recalculate like a spreadsheet, sort of like you're used to. And like, why does this matter? And why is this a good thing? I guess two things. So one is actually it just like leads to like way faster like data exploration. Like instead of having to like manually change the value of a variable and then like hunt for all the other cells that use that variable, Marimo will just automatically run them, and you can just see really quickly in real time like you know, what do the new outputs look like? So that's one. But the other one, which is a maybe more subtle, it is the reproducibility aspect, which is that because if you forget to run a cell that depends on a variable you just changed, now you can't trust any of the outputs in your notebook, and your experiment is kind of borked. So that's the main that's what reactivity gives you. And like one thing, I'll just pause because if there's machine learning practitioners or AI folks in here, the next question that always comes up, which I'll anticipate, is, oh, but like some of my cells are going to start like kicking off like a GPU training job, and like I don't want that to start automatically. Like it's expensive. I can't interrupt it. And so for those situations, Marimo does have a button that says make execution, we call it lazy. And so if you do that, then if you run a cell, Marimo will just mark the other ones that depend on that cell as stale, but it won't auto run them. And it'll give you a button to run them. So like you still get guarantees on like the reproducibility and the state, but you can rest easy that you're not accidentally spending your OpenAI credits or whatever you're doing that's expensive.
Nice. And so I guess that ties into how you've previously mentioned that Marimo's reactivity makes UI elements like sliders and plots substantially more useful than Jupyter widgets. And I guess it's because of what you just described, where in the Jupyter notebook, you don't know necessarily like those any kind of UI elements, any plots that you're outputting, any sliders you might have in the notebook, you don't know in the Jupyter notebook whether those are being updated properly based on other changes that you've made. Is that kind of where that reactivity becomes useful there, or is it something else?
Yeah, no, that's essentially it. So like in a traditional style notebook, like if you had a slider, first of all, like getting that hooked up to like even propagate its value back to Python is like kind of challenging. Like you have to have callbacks and stuff. And even if you do, like the things aren't going to automatically run with the updated value of your slider. So it's like, okay, what was the point? Whereas in Marimo, you import Marimo as Mo into your Marimo notebook, and now you have access to a bunch of UI elements, such as sliders. So you could replace the variable A I said, instead of it just being an integer, it can be a slider. And now as you like scrub the slider with your mouse, like the other cells are automatically running as well. And so that's like the interactivity feeds into reactivity to give you like a truly dynamic experience that can really, really speed up your data exploration. One concrete example, like I guess from the PhD, that sort of like really helped what I really wanted to achieve, and I think we achieved pretty early, was like you can even output plots in Marimo where you can select like a cluster of like a scatter plot like with your mouse, and then those points get sent automatically back to Python as a data frame, and then for downstream analysis. So like it really opens up like new sort of kinds of interactive experiences.
This episode of Super Data Science is brought to you by the Dell AI Factory with NVIDIA, two trusted technology leaders united to deliver a comprehensive and secure AI solution. Dell Technologies and NVIDIA can help you leverage AI to drive innovation and achieve your business goals. The Dell AI Factory with NVIDIA is the industry's first and only end-to-end enterprise AI solution designed to speed AI adoption by delivering integrated Dell and NVIDIA capabilities to accelerate your AI-powered use cases, integrate your data and workflows, and enable you to design your own AI journey for repeatable, scalable outcomes. Learn more at www.dell.com/superdatascience. That's dell.com/superdatascience. Nice. That's really cool. I appreciate the tangible example, something that's always useful for our listeners for sure. Um, and another feature that seems really cool to me is that if you when you have the notebook maybe into a state that you're happy with, you could hide the code cells, and then all of a sudden you have a data app just ready to go. Is that right?
Yeah, that's exactly right. So like a Marima notebook collapses the space between like notebooks and data apps. Now, all your notebooks can be just notebooks. They don't have to be anything more. But if you want to, yeah, you just push a button and then boom, you don't have just a notebook. You have a full-fledged data app, which by the way is actually like pretty performant. Like unlike Streamlit in Marima, you slide a slider, it's only going to run the things that depend on the slider. It's not going to rerun the whole notebook. And yeah, that data app, you can serve it on a server. You can even run it entirely in the browser with a technology called WebAssembly. So really easy to share these artifacts.
Nice. I love that. And then so it just occurred to me, this actually wasn't in our research, but if this is an open source project, Marimo, but you have venture, like Sean's invested in your company, AIX and other investors are expecting a return. What's the commercial angle for you?
So Marimo, as the open source, what we're doing is we're providing like the best programming environment for individuals to like work with their own data, and you can still use it sort of successfully at your own company or at a company. We have many people using Marimo um, in like companies very large as well as small cutting edge startups. As far as like commercialization goes, whereas Marimo is the best place for individuals to work with their own data, like there's still like a lot of gaps in order to like work with data in your enterprise at scale, especially doing like rapid experimentation with like very large data sets. And so there's a lot of unsolved problems there, and like that's where we uh, plan to commercialize.
Yeah, that sounds like a really great strategy, a great commercialization strategy. So people can get the full use of your tool as individuals. And so I think this is something that would often be called product led growth, PLG, where you have users that are volunteering to try this product out, and in a situation like yours where you're getting millions of downloads, it's obviously working well. It's about as well as PLG goes. But then there's kinds of features that enterprises are looking for around security, for example, maybe collaboration, maybe file storage. There's all kinds of ways that it would be impossible to offer those things for free to people. I mean, there would be substantial costs to the creator of that kind of functionality, and so it makes perfect sense to then be offering those as a commercial offering. And it's something that we've seen, going back a couple decades. Tools like RStudio, they followed a similar kind of trajectory. They become the default IDE for at that time using R, which was very popular for data science, data analytics some years ago, and it still is. I mean, it still gets used today, but Python is now the lingua franca in data science, and it's great to see Marimo developing a great environment. And I love how you can get so quickly uh, from a from a notebook to a working data app. That's something cool that I haven't seen. I haven't seen it done exactly like that before. Um, I think that could be great. Um, so on to my next question. You've talked about a vision where you go from and as we've been talking about this whole episode, where you go from these kind of error-prone JSON-based scratch pads that Jupyter notebooks are into a full stack developer platform where exploration and deployment converge, just as in, having a data app there ready to go instantly. So when tools collapse the boundary between notebook and application, that seems to change not just workflows, but also how roles work. So as this line blurs, what kinds of new responsibilities and skills should our listeners adapt, or does this just mean that they don't have to kind of develop engineering skills? Yeah. So how does it change things for our listeners who are, maybe developing data applications, developing models for deployment, and then after you've kind of thought about the how it changes things for an individual, how does it change things for an organization? In terms of research, engineering, operations, this something like Marimo seems to break down a lot of silos.
Yeah, that's a really good question. I think it's an astute observation. So, um, in terms of the individual, like the practitioner, data scientist, or even ML engineer, or AI engineer, data engineer, I think the way that I think about it is that Marimo gives them like new capabilities um, to like make their work just like far more useful in the organization. And that gets into your second question too. How does that change things within an organization? So the data app is like one good example. Like previously, like you may have had to, you may have done your experiment in a notebook, and then you're like, okay, where's the front end engineer who can help me like actually like build an application around this to make my work actionable. At best you might like try to reach for something like Streamlit, but like you would hit performance bottlenecks there rather quickly. It's like with Marimo, like there's no migration phase. Like your notebook, should you want it to, just change a couple of variables to like sliders or drop downs or tables or whatever you need, and then all of a sudden you have a data app that you can then share with your team, but also like to your CEO. So like actually at a number of companies that are using us, CEOs are using Marimo notebooks that their data scientists made for them. Sometimes the CEOs are actually making their own Marimo notebooks to like run their own operations, just because like the barrier entry is like so low, and it's even lower like once you consider like LLM integrations that we have, like just like vibe code your way through like a pretty simple sort of tool that you can make. So that is one way that I think Marima like gives the data scientists new capabilities and also brings new people sort of into the fold. There is another way, and it has to do with what you mentioned of like Marima notebooks being stored as Python files, because actually every Marima notebook is an executable script. It's just a Python file. Like you can go to the command line, say Python mynotebook.py, even pass a command line arguments. So like from your notebook, now you actually have a workflow that you can like run as a pipeline or as a cron. And so that's like yet another way, by like reducing that friction, we've now made you hopefully like a lot more productive. And also, there's a lot of alsos, but because it's a Python file, you can actually say like from my notebook, import my function or like import my class. Um, and when you do that, that means that like, there's famously like for like many years now, people have talked about like the notebook to production handoff, the researcher to engineer handoff. Like that makes that handoff like a lot less difficult, a lot more streamlined. Because like as Marimo nudges you to write better code and it like gives you these reusable functions, you can actually give your notebook to someone and they can import it and just use the logic. You could even write tests for your Marimo notebook. Marimo works with PyTest. Um, so that's another way that like it makes like notebooks actually more useful in the engineering context as well.
Nice. Probably during that part of the video version of this, we would have had the camera all on you, Akshay, but I was nodding my head aggressively throughout that whole time because that kind of functionality that you just described there is so useful. Like that would be like, amazing functionality in terms of being able to call my notebooks from the command line or be able to pull in classes into other programs that I've running or other scripts that I'm developing. That is super cool. And it's pretty amazing because, well, maybe it's just because it flows naturally from topic to topic. But our next question that I had for you was on exactly that. Um, so let's skip to what I had for right after that, which was around AI assistants. So this is something that a lot of our listeners, including myself, are huge fans of Cursor as an IDE, and part of that is because LLMs make it very easy to write code. All of a sudden, whole functions are just appearing before our eyes. Um, so it's kind of like an autocomplete on steroids. If people have the experience, for people who haven't used Cursor, it's kind of similar to what something like Gmail does today, or even a Google search, where you kind of get the next few words suggested. But it ends up, sometimes it's like, whole function it gets, appears in front of you in Cursor. And so it sounds like Marimo also has a kind of AI assistant involved. Tell us about it.
Yeah, definitely. So um, in the Marimo editor, so Marimo as a notebook works like most notebooks. You see something in your browser, Python cells, where you can type code in. You see outputs, and there's also there's a few different points, four I think, at which like AI is sort of integrated into our editor. Um, so the most prominent one you'll see is a button that says "Generate with AI," right? And so that's what it kind of sounds like. So you can generate Python code or SQL code, I should mention. So Marimo has native support for SQL. Um, and you can use essentially like whatever AI backend you like. So you can connect to OpenAI, Anthropic, Gemini. You can also use Olama to run local models. But the point is, what makes a notebook a unique experience, it makes our notebook a unique experience for using an LLM, is that um, well, you actually have data in memory, right? And that's really different from like traditional software engineering where it's like just text files. Here, you're like, you have a running notebook session. You have data frames in memory. You have tables in memory. So what you can do is like, you can say something like, hey, you know, using my data frame, and you tag your data frame, like using at df, do a group by the country column and like aggregate over all numerical columns. And then what Marimo will do behind the scenes, it'll pull the data frame from memory, look at the schema, get some sample values, and like pass that in as part of your prompt, so that when you get the generated code, like it actually has the column names in it, and like it'll actually work. Um, and that's like something subtle, but like you won't be able to get that from like just using Cursor on like the text files, and that alone is like a huge productivity boost, I think.
Nice. I'm so glad that you were able to, I feel kind of bad almost when, like someone like you, startup founder, comes on the show and is talking about their product. And I'm like, how about this other product? that,
No, 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 no.
so yeah, but, Cursor is something that a lot of people have experience using. And so thank you for that explanation of how it works in Marimo, and also the kinds of things you can do. It sounds like, you've been thinking about ways that data scientists in particular, or AI ML engineers in particular, data analysts, people who are kind of used to the Jupyter environment, how they would benefit most from an AI assistant, which adds kinds of features like you just described there around, data frames being populated like you'd expect. Um, so super cool. And that actually is a great segue to my next question, which is around, you've previously said that there was a joy to rethinking a system from first principles as you set about creating Marimo. So, you get to have an opinion on on how the tool should be designed. And so it sounds like, if our research is correct, you began Marimo with a 2,500 word design document. So yeah, tell us about that experience of, coming up with this opinionated tool from scratch, what that was like.
Oh yeah, it was a ton of fun. Um, so this was like right after I finished my PhD. So 2022. At that point, like we talked about, like I used notebooks a ton during my PhD. There were still some gaps. And so what I got the opportunity to do is that, I had some free space, and like I got to just like study the landscape, got to, really dig into like, well, what do people like about notebooks? Interactivity, seeing your outputs live, and also like what are people doing like in other ecosystems, like what kind of innovations what kind of ideas are people playing with, but what are they innovating on? And so that process took me through I did research basically, right? And like I that's when I discovered the Pluto notebook for the Julia programming language, which felt like something out of like the future to me because like it has these concepts. So Pluto predates Marimo, and it's a big source of inspiration. It has reactive execution. It has UI elements. It's stored as a Julia file. Um, it doesn't have the web app thing, but I looked at that and I'm like, well, wow, that's like really close to a data app, and we can build that functionality in. So that was a huge inspiration for me. Python has its own challenges of like making something like that work. Um, so then the next step was, yeah, like writing like a design doc. Like, well, how do you? It's like you're threading this needle. Like, how do you design a batteries included experience where you have a notebook, it doubles as an app, and it triples as a script or as a module, right? And like what I didn't want was like a bunch of like kludges to like, it had to feel seamless and it had to feel frictionless. And that's why there was like this design iteration. And I was lucky though, because I wasn't designing in a vacuum. So I guess part of what we didn't chat about. So like before we got funding from AIX Ventures, um, Marimo was built sort of with like close input from researchers at Stanford Slack National Laboratory, the Department of Energy Laboratory, as well as with some like uh, industry researchers at a couple of startups. And so like I would have ideas and like throw them at them and they would give feedback. And like you could see some of these early design documents and like some of the ideas were just totally horrible. But like I got to work with them to like refine them and make them a lot better. And I think that was really special time.
Hey, this is your host, John Krohn. I'm excited to announce that this Northern Hemisphere spring, I'm launching my own data science consultancy, a firm called Y Carrot. If you're an ML practitioner who's familiar with Y Hat, you may get our name. But regardless of who you are, if you're looking for a team that combines decades of commercial experience in software development and machine learning with internationally recognized expertise in all the cutting-edge approaches, including Gen AI, multi-agent systems, and RAG, well now, you've found us. We have rich experience across the entire project lifecycle, from problem scoping and proof of concept through to high-volume production deployments. If you'd like to be one of our first clients, head to ycarrot.com and click Partner with Us to tell us how we can help. Again, that's ycarrot, YCARROT.com. Nice. That does sound like a great experience. And yeah, hopefully something that's kind of inspiring for any of our listeners out there that are thinking about building a product. It sounds like you had a great way of getting going on that, thinking about the best parts, the worst parts of kind of the development experience for data scientists. You've put a great product together. It's really cool. Something that we talked about earlier in the right at the onset of the episode, and that would have come up, I'm sure, as you were developing the product in that kind of Word document, is this reproducibility issue. So the Jupyter Notebook has been a very standard tool for a decade now for data scientists, but you've cited a study previously showing that only 4% of Jupyter Notebooks reproduce their original results due to issues that you called a hidden state trap, among other kinds of problems. Do you want to dig into these kinds of problems with reproducibility that Jupyter Notebooks have and how Marimo resolves them?
Definitely. So just to caveat this discussion, I think like every notebook does have its place, and like with Jupyter notebooks, I think they are well suited to like REPL like workflows where maybe you're not shooting for reproducibility, but you're like quickly really hacking things. The issue is though, then I think like because it's such a great environment for interactive coding, people started using them and really relying on them for issues where for use cases where reproducibility is paramount, like data engineering, like science, like machine learning. And so the question was dig into some of those reproducibility issues, right? And how Marimo solves them. So two main classes. So one is the issue of hidden state, where in a Jupyter notebook, you run a cell. Jupyter's not going to run the cells that depend on it, like the cells that use its variables. And it's up to you to remember all the complicated dependencies that might flow through your notebook. And you're going to forget some. I often did, right? And so now your notebook is in some weird, inconsistent state. So that's one issue. To make that like really like pronounced, I guess is like so in a traditional notebook like Jupyter, you can like say like you have a cell that like I don't know, it's got a bunch of code in it, and maybe one thing that cell does is like create some like PyTorch model class, like instantiate some class, and then say you delete that cell, um, and then you continue coding elsewhere in the notebook. you deleted that cell, but say you didn't realize that that was the cell that defined the model class, and you really wanted that model class around. But in Jupyter, if you delete that cell, that model is still in memory for the time being, and so your rest of your notebook will work as you want it to work. But you come back the next day and you run the notebook from scratch, nothing works, and you're like, "What happened?" And it's like, "Oh crap! I deleted the cell that defined the model, and like I really needed that." So in Marimo, if you do that, if you delete the cell that defines your model variable, it'll tell you, and it'll remove the model from memory, and like it'll invalidate the other cells. You'd be like, "Yo, that variable is no longer around. Like you can't do this anymore." And so it'll catch bugs like immediately when you introduce them. Uh, so that's one big way. And the second big way is package management. And so Marima has a special sort of, I guess, opt-in package manager, which I think is really neat. So basically, if you start Marimo in a mode that we call sandbox from the command line or however, um, every time you install a package, Marimo has a very nice, slick package installation UI. We will save the package that you installed and the version as like a comment or an entry in the notebook file itself. And now when you come back to the notebook a second time and try to run it, and you do run it, Marimo will create an isolated virtual environment for you that has just those packages. So that means that like you can just send this single notebook file around and like people can just run it without even thinking about what packages they need to install, which makes them more reproducible, but also they're just like a lot more portable. It's like really easy to just create these single standalone tools and share them.
I had more aggressive head nodding there while you were describing all that. I'm gonna have to start using Marimo myself. Um, very, very cool. Um, so something else that I think is really cool about about functionality that we've learned here that I want to it's something that's so visual and so easy to understand. It's something that would feel to me like magic as somebody who has really only used Jupyter notebooks before for this kind of script development. So it sounds like it's possible. Correct me if I'm wrong. That because of the way that you've thought about data analysts, data scientists, data people's experience from the ground up with developing this tool, it allows you to do things like highlight, select the data with your mouse in a scatter plot, and then get it back as a data frame. Is that right?
Yeah, that's right. Yeah, that's an
That's
example.
crazy.
Yeah, it feels really nice. It's like, and I really needed this during my PhD and I didn't have it. Right. Like, so it really enables like really, really tangible like data exploration, data analysis workflows that were like really, really hard, if not impossible to do before.
And so how do you decide when you're doing product development, how do you decide, I guess, to put something on your roadmap at all or to, then prioritize highly a feature like this where yeah, like how do you decide which of these kinds of force multipliers to include in your product?
There's two angles, I guess, especially earlier on, right? Like when we didn't have that much feedback and it was me and my co-founder just developing and jamming, like with our built up experience of like seeing like okay like here are some issues that we've hit with working with traditional notebooks and we know a lot of others have like we have strong opinions and we think this will land and we're just going to trust our gut. So there was a lot of gut trusting in the beginning and there still is. Now with the product being more mature, there's still gut trusting for like big new features that we're working on, but we have a big community too, right? And so we can chat with them. And actually, they come to us. They're very vocal about what features they want and they don't want. Um, and I think like the way we think about it is like, is this something that like enables a broad class of users? So like data scientist, data engineer, ML engineer, AI engineer, to be far more productive than they would have been otherwise in their sort of previous tool of choice. And I think like that is like something we call them like big rocks. Like what are the thing that really moves the needle for folks? Um, and it needs to move the needle a lot, and it needs to move the needle for a lot of people. Of course, we care a lot about craft and design and visual design and usability, and so those things are just like always top of mind and they're like ongoing. But for like the big new features, that they have to be big rocks. Sort of how we think about it.
Nice. I like that, big rocks. And so you talked there about community and how you can leverage them. So, open source projects often promise community, but not every project earns it. So, what do you think separates tools that spark tons of devotion, like the Pluto project that you were describing there in Julia? Uh, what do you think separates those from open source communities that fade? And what are you going to do to ensure that you're in the first category?
Yeah, it's a good question. Like, I think honestly, like it sounds basic, but like a lot of it comes from the maintainers just being like really kind and open. Like you gotta you gotta be open. Like if you want community, you have to, you can't just say I want community, but like there are people out there who are excited and you need to encourage them to like contribute and like be really really vocal about like how much you appreciate your community and also like help them make PRs if they want to be super responsive on like your Discord. Like we try to respond really quickly to issues and especially bug reports. Like one of the feedback we usually get from our community who like file issues is that they're like shocked by how quickly we fix their bugs. Like if someone files a bug, you triage it and like fix it and ship a release the same day. Like you've kind of won a supporter for life.
Oh,
And
wow.
um, yeah, that's something that we've noticed. Something we've also noticed like from other popular Python projects, like from Charlie Marsh, Astral's like UV project. And I think like communities many levels, right? Not everyone has to ship code to your project, although many people may want to, but just encourage all kinds of engagement. Um, yeah, and just make it a fun place for people to hang out and
Nice. If
learn.
we have listeners who would like to contribute to the project, how should they get started?
There's a few ways, and it depends on how you want to contribute. So, um, if you want to contribute code, you can check out our GitHub issues, and some of the issues are tagged as like good first issue, and like these are like great places for new contributors to kind of get their feet wet and learn what the code is like. And some of them are even like improved documentation, which is, by the way, just generically a really good way to start contributing code to a project, improve the documentation. Um, Other ways you can contribute is you can just like file a feature request or a bug report. We have a little checkbox saying, "Are you willing to submit a PR for this?" And if you are, and if it aligns with our roadmap, then we'll like work with you. Um, and then more generally, we have a Discord, so you can get the Discord link if you go to marimo.io/discord. And there, like we have lots of free flowing conversation, and I think like that there's a lot of good touch points to get involved.
Fantastic. And what if this is a listener's very first, what if they've never contributed to open source before? Would you recommend, yeah, where would you recommend they get started? How should they get their feet wet with open source development?
Yeah, so actually, we do have, I think, a number of contributors who have made their first ever contribution with us. For that, I'd say like you see a typo in our docs, something like that. I think that's like a really good way to contribute. The docs ones are um, like I could be wrong, but I think if you're just making like a simple change, you might be able to like click edit in like the repo itself, like online on GitHub.com, and it'll create your fork for you and like kind of simplify that process. Um, but yeah, make a docs change. We have like a contributing.md guide in the GitHub repo that tells you about like, oh, you'll need to make a pull request. What's a pull request? And sort of walk you through that workflow.
Build the future of multi-agent software with Agency, AGNTCY. The Agency is an open source collective building the Internet of Agents. It's a collaboration layer where AI agents can discover, connect, and work across frameworks. For developers, this means standardized agent discovery tools, seamless protocols for inter-agent communication, and modular components to compose and scale multi-agent workflows. Join Crew AI, LangChain, Llama Index, browser-based Cisco, and dozens more. The Agency is dropping code, specs, and services no strings attached. Built with other engineers who care about high-quality multi-agent software. Visit agency.org and add your support. That's agntcy.org. Nice. All right. And then that brings me to maybe one of my last technical questions for you, which is this is completely beyond Marimo. And so this is going back to the research that you've done, you focused on machine learning and optimization, and as an engineer, you've contributed to several open source projects from the deep learning framework TensorFlow that probably most of our listeners are familiar with to the vector embeddings computation library. You're going to have to tell me how people pronounce this, but it's PyMDE.
Perfect.
Oh yeah. Okay. All right. So it's PY and then the letters MDNE. If people, and I'll have a link to that in the show notes. And so yeah, so that vector embeddings computation library PyMDE, um, as well as there's a convex optimization parser, which is also just letters, CVXPY.
CVX Pi. Yeah.
CVX Pi. That makes sense. And so, half of your published research relates to convex optimization. For our listeners unfamiliar with the topic, could you expand on how convex optimization differs from machine learning and the kinds of questions that they can answer? Precision, interpretability, scalability. Yeah, tell us about convex optimization.
So mathematical optimization in general is like you have some variables that you're trying to make an assignment of values to. So, for example, say we're trying to choose a good stock portfolio. The variables is how much to invest in each stock. And then you need something that tells you whether or not your assignment to variables is good. So that's a mathematical function. It's an objective function that says, hey, like what do I predict my return will be if I make this investment? And maybe it trades off. It factors in risk and into it as well. And then you have some constraints like, well, I can't invest more money than I have, and maybe I'm not allowed to short stocks. So you have some constraints. And mathematical optimization is then the process of finding an optimal assignment of values to the variables to um, minimize the cost or maximize the reward while satisfying constraints. That's mathematical optimization. Convex optimization is just the ones the subset of those problems we know we can solve super efficiently, super reliably, provably. Um, and the use cases are somewhat different. So in some sense, like machine learning, a lot of, especially classical machine learning, logistic regression, SVMs, all these are actually under the hood. They're using convex optimization techniques to fit the models. Um, in terms of like use cases out in the wild, like what are people using CVX Pi for today? It's one huge one is financial portfolio construction. So like many billions of dollars daily are like allocated through portfolio optimization problems, which are solved with convex optimization problems. Um, Energy management, like there's a lot of usage there as well, like real time control, like controlling a vehicle, landing a rocket, like SpaceX uses convex optimization to like land, like I think it's like the Falcon or something, using software developed by our lab. And so like these are cases where like you can model the world and you have some understandable constraints and you can really exploit the structure. Um, Machine learning, sometimes there's typically not many constraints or they're kind of implicit. You don't really have as good of an understanding of like, well, what is the model doing? And also, you're just trying to find a solution that's like kind of good enough that like you're going to test it out in the wild on like unseen examples. And so the use case of like finding the optimal assignment, it doesn't even necessarily always make as much sense. That said, there's a lot of overlap. So like the vector embeddings library that you mentioned, like for that to like fit these embeddings using a GPU, we used, even though the problem was in the machine learning domain, we used techniques from convex optimization to solve it really, really efficiently.
Nice. That was a beautiful explanation. As have actually all of your explanations today. You do a great job of taking complex concepts and making them seem really approachable. Like, and it isn't just the language that you use. You also have this really um, accessible tone. Like you make everything just kind of seem light and relaxed. I really like that. It's been a joy interviewing you. Actually, on the note of you making things feel so accessible, on your personal webpage, so akshayagrawal.com, which we'll have a link to in the show notes, it says that your goal is to make machine learning and math accessible and actionable. What does what does actionable mean in this context? Like, how do you what's the biggest gap today between mathematical tools and being able to take action with those tools?
Oh, I love that question. Like when you're in school or you're taking a course, especially like a traditional course, and i.e. most of them, like you're like, they're teaching you like, okay, this is logistic regression, and then like you write down like the optimality conditions by hand. You're computing some gradients, and you're like, okay, great. Like I did a bunch of, I don't know, homework on my paper, and I submitted a P set. That's fine, and that's good. Like I've done a lot of that in my life, but like to make something actionable and to make like, I think like what's really cool about our field is that like all that math, you can do real things with it, and like that's why like PyTorch and TensorFlow and JAX and like PyMDE and CDXPy all exist. It's about like, using concepts from math, and in order to like affect real change in the world. And so like that's sort of, I guess, been the theme of like the kind of projects that I've chosen to work on, from TensorFlow to CDXPy, PyMDE, and Marimo. Like even though there is no math necessarily in the Marima code base, like what it does is give you a really, really tangible, interactive environment to work with your data. And so it's making your data actionable. Like it's actually useful, and like you can actually run your notebook as a script or share it as an app or reuse the code in it. And so like I guess that theme is sort of what resonates to me.
For sure, you're building a platform to make the change that you want to see in the world. I've loved everything you said about the Marimo product today, and yeah, I'm so glad that Sean introduced us. It's been a great episode. Before I let you go, Akshay, I always ask my guests for a book recommendation, and actually, I can see, and our YouTube viewers can see, a huge bookshelf of books behind you. So, what have you got for us?
Okay, I can recommend a couple. One that I most recently read that really resonated or stuck with me, as well as one that I'm currently reading. Um, so I most recently read American Prometheus, which is the biography of um, Robert Oppenheimer. And so, like most people, I watched, or many people, I watched Oppenheimer. I'm like, I want to learn more, and I want to learn a lot more. So I read the book, and it was really fascinating because it like actually like, you know talks about it talks about not just like, the events that happened, and not just like the witch hunt of Oppenheimer that happened after the war, but also like what is like the social process of like doing science, and like what are the social factors that influence someone who is as much of a genius as Oppenheimer was, to like make certain decisions that like led him to like develop the atomic bomb. And I thought just like having that broader context was like super interesting. So that's one. Another one that I'm currently reading that I would recommend because it's already making an impact on my life is The Design of Everyday Things. So a classic in just like product design. Um, it's taken me a long time to read it because like, I'll go like 2 pages and like, oh man, like I need to go and like improve something in Marimo. And so like if you want something, if you work in design or just are like observing the world, I think that's a good read. It's already sort of made our product better.
Fantastic. Two great and very different recommendations for us. Love it. And then for people, our listeners like me, who have really enjoyed this conversation with you today, what's the best way to follow your work or connect with you going forward so that we can continue to get your thoughts after the episode?
Definitely. So I am on the major social media platforms. So me personally, on X, my handle is Akshay K Agrawal. Um, I sometimes post under the official Marimo channel, which is Marimo_IO. I'm also on Blue Sky as well. Those are the best ways to follow me personally. And then um, Marimo also has various social channels. So we're on YouTube, we're on Blue Sky, we're on Discord, and we have a newsletter, marimo.io/newsletter, if you want to subscribe, which I personally write once a month.
Nice. Love that. Thanks so much for taking the time out of your busy founder schedule with us. Running an early stage tech startup like this must be exhilarating, but also very time consuming. So it means a lot to me and to our listeners that you took that time out. And yeah, thanks for providing us with such a great episode.
Thanks, John. Really appreciate it. It was a blast.
I hope you enjoyed that episode, and I hope you liked the shorter intro to today's episode. Reach out to me on LinkedIn with a DM or a comment. If you weren't happy, or if you have any other ideas how we can improve the intro or any other part of the show, really, always love to hear from you. We assume that if you listen to the entire episode like you have today, that you'd probably still like the full outro that we usually do, so here you go. In today's episode, Akshay Agrawal covered the core reproducibility problems with Jupyter notebooks, such as hidden state traps, where cells can run out of order, JSON file formats that break version control, and missing package dependency tracking that makes notebooks impossible to share reliably. He talked about how Marimo's reactive execution model that automatically runs dependent cells when variables change ensures your notebook state always matches what's displayed on screen. He talked about advanced interactivity features in Marimo, including UI elements like sliders that trigger real-time updates, the ability to select data points directly from plots and receive them as data frames, and an instant conversion from notebooks to deployable data apps. That's cool. Akshay also talked about the technical innovations that make Marimo notebooks stored as pure Python files, enable command line execution, function imports, and seamless integration with existing development workflows. And finally, we talked about how you can get involved with open source projects like these Marimo notebooks if you'd like to as well. You can get all the show notes, including the transcript for this episode, the video recording, any materials mentioned on the show, the URLs for Akshay's social media profiles, as well as my own at superdatascience.com/911. Thanks to everyone on the Super Data Science podcast team, our podcast manager, Sonia Brajevich, our media editor, Mario Bombo, our partnerships team, which is Nathan Daly and Natalie Jaisky, our researcher, Serge Massis, writer, Dr. Zara Karshay, and our founder, Kirill Aromenko. Thanks to all of them for producing another excellent episode for us today. For enabling that super team to create this free podcast for you, we are oh so grateful to our sponsors. You can support the show by checking out our sponsors' links, which are in the show notes. And if you're interested in sponsoring an episode yourself, you can get the details on how by making your way to johnkrohn.com/podcast. Otherwise, please help us out by sharing the podcast, sharing this episode with someone who would enjoy this episode. Review the episode on your favorite podcasting app or on YouTube or wherever you watch it or listen to it. Subscribe, obviously, if you're not already a subscriber. But most importantly, I hope you'll just keep on tuning in. I'm so grateful to have you listening and hope I can continue to make episodes you love for years and years to come. Till next time, keep on rocking it out there, and I'm looking forward to enjoying another round of the Super Data Science podcast with you very soon.